Hello, welcome to our review video for lessons 9.5 through 9.8. If you go to page 605 in your book, is kind of where these sections are for the review pages. Before we look at those, just kind of a quick summary recap of some things that we looked at in these sections. So one of the things we looked at was completing the square, or we learned later another option was quadratic formula. And again, you can decide either way. I'm not going to make you work those problems out one way or another. Another thing we talked about was the discriminant and the number of real solutions. Remember, the discriminant was the part under the square root in our quadratic formula. That was the b squared minus 4ac part. That would be under the square root, and that determines how many real solutions we have. We also talked about looking at a table of points or at a graph and determining if the function is linear, quadratic, or exponential. Also, just besides looking at the points graphically, we talked about other ways that you could figure that out without graphing the points. And then finally, solving algebraically the intersections of linear and quadratic equations. So these will be the ideas we'll be looking at as we go through these problems. Section 5 was on completing the square, and like I said, I'm not going to make you do these problems a certain way. And having said that, if you look at these, remember to complete the square, you can't have a number in front of the x squared. I mean, if there's a 1 there, obviously that's the same thing. But if you look at number 32, all of those terms would have to be divided by 2. And so 7x divided by 2, you're already going to have a fraction in there. It's not going to be real pretty. So for sure, I don't think I would recommend doing that one that way. 34 is kind of a different story because those would all have to be divided by 4, but those all come out evenly. So not as big of a deal there. But anyway, just something to think about. Number 30 is the only problem I'm going to look at in this section. Again, just because you have different options and just with the idea that some of you might be choosing to complete the square, or use quadratic formula anyway. So technically this is already set equal to 0. So we could try to see if this factors. And it might look really good at first. It's like, oh, we got a 5 there, there's a 6, 1 and 5 make 6, right? But remember, since this is a minus 5, 1 has to be positive and 1 has to be negative. So we could switch those around. Is going to be the closest we're going to get, which would be plus 4x. So that does not work. So we are going to have to go with either completing the square or quadratic formula, and like I said, I will do completing the square on this problem. So I've got kind of a mess there. Let me move that maybe if I can. Okay, so completing the square, what we talked about is basically that c value isn't what we want it to be. So they're subtracting 5. We're going to add 5 on both sides. And then we're going to leave a blank because we're going to be adding a number on both sides of the equation to make this work out nicer. And so if you remember how we did this, we have to take half of our b value, so half of 6, which is 3. And then if we square that, would be 9. So we're adding 9 on both sides. And really, I mean, if you want to not have to think quite so much on this, you could say, well, I'm going to take half of b and then that's going to tell me the number that needs to go in each of the binomials, and then if you just FOIL that out, just figure out what number do you need. You got x squared, altogether you've got plus 6x, and then when you multiply the 3 times 3 you get 9. So, you know, there's kind of two things to remember there, but really just taking half of b is all you really need to worry about memorizing necessarily. So 5 plus 9 is 14, and we have at that point a binomial square. And that's kind of the whole point of completing the square. We want a perfect square so that we can take the square root on both sides. Remember, when you add the square root sign, you need to do plus or minus in front of the square root. And then over with the x, they're adding 3. We need to subtract 3 on both sides. So the exact answer would be -3 plus or minus square root of 14. And then at that point, it would be a matter of, we could type those into our calculator and see what we get. So -3 minus square root of 14, or -3 plus square root of 14. Those are the two solutions that should work. And so if you work this out, they said nearest hundredth. So this should come out as -6 and 74/100ths. And this should come out as 74/100ths. So those would be the estimated solutions. And again, this that we did earlier would have been the exact solutions to that problem. Lesson 6 was on the quadratic formula and the discriminant. So if we look at number 38, they're wanting us to find the number of real number solutions for the equation. So to find the number of real number solutions, if you remember, what we needed to look at was the discriminant, which was the part that's underneath the radical in our quadratic formula. So before we do that, let's go ahead and look at what these different values are. If you want to just jot them down separately here, you can. Oh, one thing we need to make sure we do first is we've got to have this set equal to 0. So actually we'd need to subtract 3 on both sides. And I'll just come over here because we'll have room there. Okay, so that actually makes c equal to -13. And make sure you don't lose the signs. If you want to add the opposites on anything where they're subtracting, you can do that. So I'm going to write this again. The closer together all this stuff is, the less chance of us making a mistake here. So b is 7, so we've got 7 squared minus 4 times 1 times -13. So 7 squared is 49. And then 4 times 1 is 4. And then if you look here, you can add the opposite if you want. You don't have to. But basically we've got -4 times -13. So negative times negative is going to be a positive. And that would be 52. And so if you add those together, that's 101. And we're not worried so much about exactly what the number is as we are about whether it's positive, negative, or 0. So since that came out as a positive answer, that means we would have something plus or minus square root of 101 over something. So that means that we have 2 real solutions, or 2 real number solutions, you could say. And again, for those, you should be able to look in the back of your book to see answers. If we go ahead and look at number 41, and this one, it said to solve using the quadratic formula, round to the nearest hundredth. So first thing would be, once again, we need to set this equal to 0. Always the first step we need to consider for a quadratic formula. And then if we can recognize what our A, B, and C values are. And I'm going to write the quadratic formula down. And like I said, I will provide that on the test, so you don't have to memorize that. So we just really got to watch our signs here. At the very beginning, that's the thing that gets people sometimes. It's negative b, so we bring the negative down. B is negative 3. And then negative 3 we're going to square. Make sure you put it in parentheses. A is 2 and C is negative 20. And then it's kind of just a matter of simplifying this. Like I said, I don't get too calculator crazy unless the numbers aren't very nice. Negative 3 squared, so that's negative times negative would be a positive. And then 4 times 2 is 8. I'm going to go ahead and simplify the denominator. 2 times 2 is 4. And then here, you can add the opposite if you want. But that's like a negative times negative, which would be a positive 160. Add those together. And I guess I'll try and stay in this box here. Running out of space, but so if you work that out, that should be 13. So we've got either 3 minus 13 over 4 or 3 plus 13 over 4. So 3 minus 13, that'd be negative 10 over 4. 3 plus 13 would be 16 over 4. And I apologize, I'm kind of all over the place with this, but then if you divide that out, well, you could just reduce it's negative 5 halves or negative 2.5 if you want. And 16 divided by 4 is 4. Okay, and again, with this one, it did say nearest hundredth, so I guess if you think because of that we should do a decimal, probably be okay. Again, generally, we're going to stick with even, if it's not a real life problem, even an improper fraction, if it's reduced, is probably fine. But, especially that square root came out evenly. That's not always going to be the case, but since that came out evenly, that made things a little easier for us to work out at the end. And then finally, from this section, if you look at number 46, talks about a ball being thrown in the air, and they have an equation for the height of the ball. So remember, we've got gravity acting on the ball, we've got the initial velocity the ball was thrown at, we've got the initial height. And again, you don't have to memorize that equation. If anything, I would give you the general equation if you have to substitute any of those things into that. But the question is basically, when will the ball hit the ground? So the ball is going to hit the ground h is the height of the ball, so it hits the ground when the height is 0. So doesn't look real great for trying to factor or anything, so I'm just going to go ahead and go with quadratic formula here. It is already set equal to 0, so that part's taken care of. So this time b is positive, so when the negative comes down, and then b is 20, and then so we got 20 squared minus 4 times negative 16 times 6 all over 2 times negative 16. So these numbers are a little bit bigger. Negative 4 times negative 16 would be a positive 64. I'll try to not go work in circles this time. So 384. So that's not looking real great. Although, actually, square root of 784 happens to come out evenly as well. So this is not going to be what normally happens, but square root of 784 is 28. So we've got negative 20 minus 28 all over negative 32, or we've got negative 20 plus 28 all over negative 32. So this would be negative 48 divided by negative 32. This would be 8 divided by negative 32. Negative divided by negative is positive. And if you divide that out, it's 1.5 or 1.5 if you want. The other one, we could just think of reducing. Those both reduce by 8, so that's going to be the same as negative 1/4. So we're not really going to say after negative 1/4 of a second the ball hits the ground. We're not going to take a negative answer here, so we'll say basically after 1.5 seconds the ball would hit the ground. And again, think about this as an upside down parabola, and it's basically we're restricting it to the first quadrant more or less. You know, over here somewhere was where that negative answer came in, maybe a little closer to the axis, but anyway, a lot of times those problems where something's being thrown like that, there's just one answer that works and then the other one doesn't make sense for the problem. Lesson 7 was where we were trying to figure out which model would be most appropriate for the data set. So for number 47, one thing, if you'll notice, their x values are not all in order. So this one, if we were going in order by the x values, this one would be over there. But even at that, we've got -3, then -1, then 1, then 2. So we're not consistently going just to the next x value. So, you know, again, there's really nothing to say that just graphing that is a bad idea. I'm never going to look at somebody's paper and be like, oh, you graphed it, sorry, it's wrong. So anyway, if you graph those points, then you can tell that that would be best as a quadratic. It's kind of opening, it's kind of all over the place, a little scattered, but you can see enough of it that you can see that it would open down and it would be kind of an upside down U shape, like a quadratic function. 48, same idea. If you just graph those points, again, they're not in order by any means. We do have a 0, 1, and 2, so that's probably enough. You could just take those points that are in a row if you wanted to analyze the differences of the y values. You could do that. But otherwise, if you just graph the points, graphing the points, they're kind of going like this somewhat, and so that's going to be exponential. Exponential decay, we call that one, versus exponential growth, where something increases. This one's going down, so it's called exponential decay. And the last parts here, the directions say write an equation. I'm not going to have you write an equation on the tests. We're just going to continue and just say, let's find just what would be the appropriate model for that. Okay, and you guys could definitely come up with an equation for this, but that's not just really our main focus. So I look at these positive values first, and then that kind of leads me into working with the negatives. And you can see x is increased by 1 each time finally. Y is increased by 3 each time. And so our change in y over change in x, or the slope, is always staying the same. And so that means we have a linear function. And again, this would be very easy for us to even come up with the equation. Linear is y equals mx plus b. We already said the slope was 3. And if you look at the table, they've given us the y-intercept. So easy enough, there would be our equation. But again, I'm not going to ask you that on the test. Just make sure you know how to figure out, and whether figuring out could be just by graphing the points, whether it's linear, quadratic, or exponential. Lesson 8, like I said, the book talks about solving by graphing for some of these, and again, it's not a bad idea to practice some of that so you know how to work the calculator if you're allowed to use that for something. But again, we're not going to use that for the test. We're going to work these out by hand. So let's look at number 55. So on 55, we're going to solve this algebraically. We're going to see where this parabola and where this line intersect. Both of these are y equals, so let's substitute. I like to have a positive x squared term, so that's why I'm going to do it this way. And again, if you want to do this in multiple steps, that's fine. And at this point, the numbers are not looking real promising there, and these are kind of big numbers, and there's no GCF we can work with at all. But signs are going to be different. If you try and think of some close factors, obviously 1 and 96 isn't going to be real great. 2 and 48, 3 and 32, 4 and 24. We're getting a little bit better now. 6 and 16, 8 and 12. Now remember, there's no number in front of this squared term, So the signs are different. Really, all we have to do is find factors that have a difference of 4. So that would be, as it tends to be a lot of times, the closest factors to each other. So we want more negatives, so I'm going to put the bigger number next to the negative or next to the subtraction sign. And so either x plus 8 equals 0 or x minus 12 equals 0. So x equals negative 8 or x equals 12. I'm not quite finished yet because I want to find the coordinates of the points where this is at. So I'm going to substitute those. Let me see if I can copy that and move it over where I can have a little bit more room to work. So if x is negative 8, I'm going to substitute this into the linear equation. And that would be 3. So there's one pair, negative 8, 3. And I know I've been kind of working around this, but if I was doing this on a test, I would for sure substitute it into the other one and make sure I'm getting the same answer. Now remember, negative 8 needs to be in parentheses when we're squaring that. And like I said, I wouldn't even touch the calculator for this part, at least at the beginning. Negative 8 squared, negative 8 times negative 8 is a positive 64. So many times I see people, they know a negative times negative is a positive, but just by entering it in the calculator, they type it in wrong, and then they get the wrong answer. So don't do that. You guys know how to do this stuff. Okay, so that equals 3, and that's what we got over here, so that looks good. So negative 8, 3. And then if we try 12, x equals 12. Again, I'm going to rewrite my equation so I don't have a transfer error by trying to look way over at my book and looking at this. Had to check my answer there real quick. This wasn't looking very good, but okay, so 123, that would be a good one to graph, wouldn't it? And then put 12 back in for x. So 12 squared is 144. 2 times 12 is 24. So that's 168 minus 45. And that also would be 123. So that looks good. So 12, 123 would be our other solution. And again, the other one, if we can find it here, was negative 8, 3. A lot of the stuff the book's doing, they're not having a whole lot of variety here. All of their answers in this section, they're coming out with 2 solutions. And we talked about these are not always going to intersect at 2 places. So we're going to do a little more variety here than what the book's giving you, because it's not very realistic to always have 2 solutions, which might lead you to an idea about what's going to happen here, but that's okay. Okay, so let's say we're looking for where these two functions intersect. And they're set up real nice for substitution. I'm going to come over here to the left side of the screen. So I've got a little bit more room to work. So let's set this equal to 0. If you want to set it up for completing the square, go for it, but I'm going to do it this way. Okay, so we could try to factor this, but all the signs have to be positive, and so that's not going to work out very good. So I'm going to go straight into quadratic formula. And I'm just going to go ahead and substitute in. So negative b, so negative 1 plus or minus square root of b squared, so 1 squared minus 4 times 1 times 32. Okay, I recommend writing the formula down every time, but okay, so we get to this point, and here's the problem. We have a square root of a negative number, and so what that means is we're going to have no real solutions, which means those graphs do not intersect each other. Okay, and then let's do one more while we're at it here. So y equals x squared plus 2 and y equals 2. So I'm going to substitute. And notice there's no x term here. Since there's no x term, one option you have is just to get the squared term by itself. And then you can take the square root on both sides. Square root of 0 is 0, whether it's plus or minus. And this really seems familiar, so maybe this is the exact question that I did in that lesson. But anyway, the answer would be 0, 2. And again, we can substitute that into our other equation as well. If you put a 0 in for x, do we get 2? And we do. Okay, I did this one first, so it was already y equals 2, so that's why I didn't work anything out there the first time. So that has one solution, and so that's actually a parabola and then a line that just intersects it in one spot. This is page 607. So on page 607, if you want an idea of what's going to match up with what we just did, 12 through 14, those are from lesson 6. 15 through 18 are from lesson 5 and 6, which was completing the square and quadratic formula. And then 19, that goes with 9.5 and 9.6 as well. 20 goes with lesson 9.7. 21 and 22 goes with lesson 9.8. So those would be the ones I would key in on for reviewing this. I don't want to make this thing be like an hour long or anything, so what I'm going to do here is just go ahead and put the answers on here so you know what the answers are. I know for the other pages in your book you already know the answers, but This way, if you guys choose to do these as some of your review problems, then you can check your answers. So I'm going to start saying answers, so you may want to pause this if you're not wanting to hear those yet. So number 12, number of real number solutions would be 1. 13 is 0. 14 has 2. So they had good variety that time. 15 would be -1 and 3 1/3. Make sure you remember to set these equal to 0 first. If you don't set them equal to 0, you won't get the right answers. 16, nearest hundredth is 24 hundredths and -4 24 hundredths. 17 is 1 and -2 1/3. And 18 is -8 and 2. And then if we go over to the other column here, number 19 is nearest hundredth 2.06 seconds. 20 would be exponential. I'm not going to require you to find the equation for that, but if you're curious, it would be y equals 40 times 5/10 to the x. 21 is -1285 and 4/5. And 22 is -4/6 and 3/13. So hopefully with all that gives you an idea of what we're looking at in lessons 9.5 through 9.8. Again, you have the PearsonRealize.com website. You guys can look at some questions on there to get some more practice on this. If you have any questions about any of this stuff, if you want to give me an email, send me an email or something to let me know about any questions you have. And have a good day.